Okay. Good afternoon, everyone. Today we're just going to be going over the midterm, so preparing for the midterm review. Before that, if you have any questions about the project, any questions about any of the homework or anything we've reviewed so far? Yeah.
With the resubmission for projects,
Yes.
if we turn it in, we get it's at 8 points, right?
It's out of 8 points, yes.
If we got a 7 and then resubmitted with the bonus stuff, would we get 9?
Yes, you can get 9. So one of the goals of this class, or one of the principles that I try to adhere to, is to reward you for doing well rather than penalize you for missing a deadline. So if you do all the extra credit, you can actually get more than 100%, even if your submission is late initially. So. Okay, so we can begin by talking about the last homework. So this was homework 13. What are the basic steps of a command line processor? So what were the 3 steps we saw in the last lecture?
Read instruction, execute instruction, and then on exit.
Okay. That's almost all, that's generally right, yes. There's something else maybe more specific going on after you read the instructions as well.
Parsing information.
Yes, parsing the input. So what is parsing? Yeah, tokens or any kind of structured form. For us, we were just looking at tokens. Yeah. So I guess what's the difference between a parser and a recognizer? Sure, so a parser does verification while it's parsing. That is correct, yes. But what does the parser do specifically that the recognizer doesn't? Yeah.
I think it breaks it down for later use, right?
Sort of. Yeah, that's a way of saying it, yeah.
A parser creates a data structure and the recognizer just does the grammatical checking.
Yeah. So a parser specifically parses the input, converts it to some structured form in memory, whereas a recognizer just verifies that the input conforms to some grammar. That's the difference. Has anyone started the proc project? I know it was just assigned a few days ago. Yeah? Okay. You did it? Okay, cool. All right, so speaking of projects, I want to just reiterate something here because my find, I think, is due tonight, right? Okay, so remember, if you read section 5 of the instructions, it tells you that your project will only be ran and tested in this way. So, well, we're going to be running the test cases separately, but for building your project, you have to be able to, we have to be able to automatically with a script cd into your project's directory, run make to create the binary, and then run the executable binary myfind, like so. So you don't want to push the executable to the Git repo. Only push your source code, your make file, and your README. So if you accidentally push your executable to Git, that shouldn't cause any problems in this case because I think we have it set up to where we'll delete any binaries that are already in your repo before running make, so that way we don't accidentally run the incorrect code that's stale, any stale executables. But in general, you don't want to push executables to source control because your make file should tell anybody who's using your program how to build that project. You shouldn't have to push the executables themselves. Okay. So with that, I think we can start talking about the exam. So yeah, I wrote the exam like 2 weeks ago, I think, and I've updated this page to match what's on the exam. So you can expect that what's on this page should be a superset of what you will find on the exam. It's not going to be too much more. Some of these concepts on here will not be tested, but I can't tell you exactly what's on it. But everything on here is fair game on this review page. So for the exams format, just some logistics, there are going to be 20 questions. 16 are going to be multiple choice, each worth 1 point. 3 short answers, also worth 1 point each. And then 1 long answer that I'm making worth 5 points. And the total is going to be 24. The midterm exam counts for 8% of your final grade, if you recall from the grading breakdown on the homepage of the course. So to get your final grade, your final percentage points towards your final grade, you just divide your total score, 24, by 3. So I try to keep it all simple and work with even numbers, round numbers when you're doing this. So for, I guess, logistics, some other things that I'll mention, when you come to class next Monday, bring your laptops. So we're going to be taking the exam in class on web courses. There'll be proctors walking around to ensure everyone's being honest. And if you can't bring your laptop, then I'll have paper exams ready. I printed them this morning. I have 25 paper exams that I printed. There's, I think, 100 students in this class, so I'm hoping that no more than 25% of students will need to take the paper exam. So please bring your laptop if you can. If you don't have a laptop, you can go to LibTech at the UCF library and rent one for the day. Yeah.
Is it going to require lockdown or just normal web browsing?
No lockdown, just regular web browsing. So yeah, but it's a pretty small room, so we can easily see everyone's screens. And we can go to the back too, so you can't hide in the back or anything, so yeah. Yeah.
Is it gonna be on campus then or somewhere?
It'll be on campus. Yeah, it'll be, you mean, you sit on campus, right, not on campus?
Yeah, like
Yeah,
web courses.
yeah, it'll be web courses, yeah. And you'll have to present your student ID. So on exam days, I take attendance manually, so when you're done, you'll have to walk up to me, present to me your ID, and then I'll mark you as present and have your exam. This is to prevent anybody from taking the exam outside of the classroom or maybe taking the exam for someone else, for instance. So. Okay, so any questions on logistics? This is all on the midterm, the homepage here as well. You can click on midterm exam, and this is all here as well for reference.
Short and long answers, are they like kind of coding based?
Yeah, so the short questions will be writing typically 1 or 2 lines of code, not much more than that, or yeah, just about 1 or 2 lines usually. Whereas the long response is going to be a complete program that you have to write. Mm-hmm. But again, most of this course's points are based on the projects. So do well on the projects. I have had people in this course in the past not do very well in the course, even though they did excellent on the exams because they neglected to do the projects on time. So just make sure you're staying on top of everything. Yeah.
Do like the cheat sheet or the 8-paper cheat sheet, is that
Yeah.
gonna be typed out or handwritten?
You can type it, you can handwrite it, whatever you want to do. So again, you get, yeah, I'll mention this as well. You are allowed 8 pages of notes, double-sided. You can bring, yeah, printed out notes, typed notes, written notes, whatever. You can have man pages printed out, whatever font size you want, just 12, yeah, 8 pages. In the final exam you get 12 pages, but for the midterm you get 8 pages, double-sided. Yeah.
As far as the 8 pages of notes, is there any restrictions of what we can write on there, or is it just anything?
Anything, yeah. Mm-hmm. Yeah.
Format is multiple choice.
Oh, this was in the previous slide. So it's 16 multiple choice, 3 short response, and then 1 long response. Is that your question, or? Okay, yeah. Yeah.
Would you recommend the notes, I wouldn't say focus on, but if you were to, I guess, bring a cheat sheet, what would you have? Like, would you have just man pages or like a combination of everything?
I don't want to give you the answer of what's only going to be in the exam exactly, but I would say maybe include examples of everything we talk about. Examples that cover, maybe not an example per every question here, but examples that collectively cover all the topics listed on today's review, and that should be fine. So you might not need like 1 example for every bullet point. You might only need like 1 example for every heading, and as long as it covers everything you talk about, everything we talk about today.
And
Yeah.
is it possible to get a good grade without a cheat sheet?
Yeah, definitely.
Okay.
I mean, yeah. Most of the students that I've known who have gotten really good grades in the exam without a cheat sheet, they already had some prior programming experience, but I think it's possible to get it without prior experience if you just study, yeah. Okay, so I guess we can begin with the actual review. So first topic here is file systems. What makes the Unix file system hierarchical? Yeah.
Parents and children, and they inherit like traits from them, like they would inherit like processes and stuff from them.
So that's processes. We're talking about file system. So similar, but yeah.
You're talking about the file explorer, how it's organized in folders?
Yeah, so there's a directory structure, correct? There's directories, and then underneath each directory you can have children, other files, and can the files underneath the directory also be directories? Yeah, so that's what makes it hierarchical, because once you have directories that are subdirectories, then you get this tree-like structure. So remember we had seen the tree command listing contents of a directory. In a hierarchical view, that's an example of how you can see the hierarchy. Okay, what is the difference between absolute versus relative paths?
An absolute path is a complete path from the root to the destination, and a relative path is a path based on your current directory.
Yes, the current working directory, exactly. So what's the easy way to check visually that a path is a root directory, or absolute path versus a relative path? Yeah, it begins with a leading slash if it's an absolute path. No leading slash, it's not an absolute path. That's like the quick and easy way to tell. So what special file do we use to reference a parent directory? Yes, the two sequential dots, yeah. So this is an example of a kind of question that might be asked. Given a file tree, which file is being referenced by a given path? So to study this, you could review, I think it was homework 3 here? Yeah, or not 3, sorry. You could review 2, you could also review, I think it was, yeah, this one, 5. This would be a good one to review for studying the, being able to identify what kind of path path is referring to, what kind of file a path is referring to. Yeah, I'd also recommend reviewing the homeworks. The homeworks also provide pretty concrete questions for you to gauge your understanding of the material. Okay, so let's go back to the review. And the last one, draw a file system tree. So given a table like we saw in that page that I just showed, let me open it up again. Homework 5, I can get back to it. Yeah, given a table like this, you might have to draw a tree. You remember how to do this? Want to see a review? Yeah.
I was gonna ask.
Okay, sure. So I actually have slides that I think we can use to do this. So this was the homework for what lecture? This is 5, so this should be homework. Syscalls is the lecture we were at. So I think Syscalls. All right, here we go. So I presented these slides earlier, but I think it's good to review them now. So we have the home directory, and this is an absolute path. Then where should the home directory be on the right-hand side here? Just under the root, right? Let me page down. There we go. And then the dev directory, where should that be? Under the root. So it's absolute, and it's underneath the root directory, so it should be under the root as well. So the boot directory, this is an absolute path. Underneath the root, or underneath the absolute, this is the working directory on the right here. So the working directory is /dev. It's an absolute path, and we say /boot. So under the root as well. So a relative directory, first relative, yeah.
Like, you just find out, like, it will fit in the dev directory, but under direct root.
So we're in our current working directory is dev. So if I go into my command line here, and I say cd/dev, and I'm in the dev directory. You can see all my contents by dev directory here. But if I say cd/boot, this would change my working directory into the boot directory, starting from the root directory itself, going down from the root directory to the boot directory. Yeah. So it's, if you remember, with absolute paths, it doesn't matter what your current working directory is. If you start with the root, everything's going to be beginning right from the root. You're giving the full path to the file. Yeah.
If we're doing something like this and we're not more than 25 people, max doing it by hand, then instead of drawing it, is it okay if we format this in the way that Bash does it when you give it the tree command?
Yeah, that'd be fine.
Okay.
Yeah. And you might not be asked to draw a tree, but to go the other way around and use a tree to identify what a file is given your current working directory, where a certain file is. So. Okay, so next one, the user directory. That's relative to the home directory. So where should this be? Under the root? I'm sorry, I should have said the root directory. I misspoke. Okay, Paul relative to the, this one's relative to the home directory, so that would be underneath where? Home. And here we have the first occurrence of the parent directory. So we're starting in dev here, and we're going up one directory, and then we're going into home, Paul, and then source. So where should this be? It'll be under Paul. So we're in the dev directory. We go up one to the parent directory, the root directory. We go down to the home directory here, then Paul, and then the directory underneath this would be source. So now the bin directory, it's relative path underneath the user directory. So user is here, so where should the bin directory be? Yes, exactly. And then here we have another relative path. So we're in home Paul, so we're in home Paul, and we're referring to the ./bin directory. So what does dot refer to? The current directory. So where should this end up being? Yes. And then here we have, again, we're at home Paul, and we're referring to a directory called home. This is a relative path. So what should this be? Where should this go? Under Paul as well. So it's kind of weird. It's meant to be a little weird. Now the last example, we're in the dev directory, so /dev. Up one parent, so we go back to the root, go to the home directory, Paul, home, and then we are referring to a relative path, a directory named Paul. So where should this be? Yeah, exactly. So I hope that was a clarifying example if you had any lingering questions about absolute versus relative paths. All right, can I close this? Okay. Are we good? Okay, let's continue. And if you want to see that again, you can go to the lecture videos for the syscalls lecture, and it should be in the beginning when we go over the homework. Okay, navigation. What is the working directory and how do you display it?
PWD.
Yes, so PWD shows you it, and it's the directory from which all relative paths are relative to, essentially. What is the Unix standard command to rename a file? Yep, MV. What is tab completion?
The presses tab.
Yeah, just pressing tab to automatically complete the name of any file in your current directory, or in some cases, arguments to commands and flags. Yeah.
When you have a question or anything related to like tab completion and like, being character specific, if it's like uppercase and stuff?
No, because that depends on bash settings, so no.
Okay.
Yeah.
Bless you.
what Unix command will show you the text of a file? Yeah, cat. What does grep do? Yeah, pattern matching. So searching for text within a file based off a given pattern. But we've mostly just been using exact patterns, so just words in this course. How do you change the working directory to your home directory?
Slash home or tilde.
Yeah, so cd, you can use a tilde, or you can cd/home. Or if you really want to, you could also say cd and then $home. That'll expand, that'll be the bash variable home. This will expand to my home directory, so that also works. Any one of those works. And actually, /home is not really correct because that's more like the home directory. It's not your user home directory, so it would have to be /home / your username. So tilde or $home, one of those two. What is the Unix command to delete a file?
Yeah,
What are the letters? RM. Can we use this to delete a directory? So not directly. What do we have to pass to it to delete a directory? -r, right? So R stands for what? Recursive. What about rmdir? rmdir. Does that work for deleting directories?
It's empty.
Yeah, only if it's empty. So
it's not that it names it right.
if it's not, it doesn't actually work at all. So if I were to run, remove my, well, that doesn't work because it's busy, but rmdir, well, that says on permission denied. Let me see if there's just a directory I can make here. rmdir, music, I guess. Well, I guess I had no music in my directory, so that actually worked. Yeah, again, this permission denied, but there's no, these are not empty directories, so that's really why. I'll just make a directory really quick to show this. Yeah, make dir, a touch a/test.txt, and then if I try to remove a, it'll say directory not empty. So, yeah. And then what can I use to delete it anyway?
Force line.
-r. So what does -f do?
Force, just like
Force, so it also throws no warning if the file doesn't exist. So if I were to say rm test.txt, I get a warning because it doesn't exist. But if I add -f onto that, then I don't get a warning. This is useful for what? When do we use -f usually?
Make clean.
Yeah, and clean rules for make files. So we don't get errors when we try to clean our project and the outputs are not present. How does the implementation of deleting a file work? Does it actually remove the file's contents from the storage medium? No. So what does it actually do?
Just the reference to the file.
It removes, what is that reference called?
Inode.
Does it remove the inode? So what is RM doing? If I have on my desktop again, I'm gonna leave this open. Actually, what I'll do is go to the directory I had open earlier. Or no, I'll just go to the desktop, I guess. If I have a file, hello.txt, just as hi, and I create, how can I create a link to this file? What command do we use for links?
Is it LH for a hard link?
Close, close. So I can use ln to create a hard link to a file. So I can say a.txt, or I'm sorry, hello.txt, and we'll call the link hello link.txt. And now if I do ls dash L, you can see I have these two files here. Dash I1, you can see the inode numbers are the same. So if I remove the original file now, hello.txt, and open hello link, is this going to work? Well, it will actually. So what was the analogy we had said for hard links? It's like an extra door on your house. So if you destroy one of the doors, the house still stands. So if we use RM, is that actually deleting a file? What is it deleting? The hard link. Yeah. So a directory is really just a mapping, we had said this, is a mapping of file names to their inode numbers. So when you run RM to delete a directory entry, to delete a file, you're really just deleting that mapping in that hash map that's the directory. When you delete all the mappings, when all the mappings from file names to their inode numbers are gone, then the file is actually deleted. And when the file is actually deleted, is it actually scrubbed from the storage medium? No. What happens?
Eventually it's overwritten.
Yeah, it's just the space it was using is just now free real estate for anybody else to use. They can just overwrite it as they like. Yeah.
After you remove the link, is there a way to like retrieve it back or no? Since it's technically it's not completely gone until you overwrite it, is there a way to like retrieve it back or no?
So that's a good question. If you were to take, I think we have a class here, digital forensics. I don't know if the same professor teaches it, but he shows how on Windows systems at least, you can inspect memory in a machine after it's been deleted. And he actually explains, because I think the professor who teaches it, he is also in the police force, and he shows how they actually use this in real world settings to catch like child predators and whatnot, people who might have nefarious files on their computer. When they try to delete it, they can actually recover the information, the incriminating data. And it's really a cool course because they actually show you how you could how you can actually go to deleted files and totally recover hidden video files and everything in a course. From a disk. So it's pretty cool. I think it's digital forensics is the name. So yeah, there is ways to do that, but it's just not like immediately obvious. Yeah.
Just a quick question based on that. How would you know that something is hidden or like deleted? You just like just pretty much do it just to see. Check?
You'd have to. So I forget exactly how you do this, but you'd have to look at other files and like timestamps, and you'd also have to just have a reason to suspect someone. Of course, you need access to their device as well. So yeah.
Just do a memory dump and then just compare it with whatever you can see currently, like a snapshot of whatever you have. It'd be the way to do like a dev mode to do like everything.
Okay, sure. So yeah. Yeah.
Just out of curiosity, is there some kind of a command to shred instead of just,
I think there is a command called shred. Yeah, I don't know if that's what you were trying to get me to, to mention, but there is a command called shred. Yeah. I haven't used this one before, so I'm not that familiar with it, but I know it does exist. Yeah.
I just wanted to mention that shred technically usually does a good job, but it's not perfect. So
Yeah. I think most tools are not going to be perfect at totally deleting things, but yeah, thanks for pointing that out. Okay, so any other questions about that? There was a lot of cool discussion there. Okay, what is the difference between hard links and soft links? We had just talked about hard links extensively, so what is a soft link then? A tunnel was the analogy, right? So if I delete a soft link, it's not going to affect the original hard link, but if I delete a hard link, so I can create a soft link with the -s flag, soft link to hello link, and I'll say hello soft link.txt or symbolic link. Will this have the same inode number as the other file? No, it'll be different because this is a soft link, so it's its own separate file. And if I delete hello link and then try and open hello soft link, what's going to happen? Yeah, I'll get nothing, essentially, just an error. You can see it here, it's a dangling link. The file no longer exists.
So, hard links better than soft links?
It just depends on what you're trying to do with them. So hard links will be the same file's contents. A soft link, sometimes you might want a different INO number, sometimes you might want to have a link that's relative. Soft links can be relative links, which is sometimes nice as well.
Can you stack links?
Yes, you can. You can have links to links. Yeah. An example of this would be the dev/stdio, I believe, is a symbolic link, or standard out, sorry. This is a symbolic link, and if I were to follow this link, it would be another symbolic link. So you can try that on your own time, but yeah, there are cases where you have recursive links. Okay, what shell built-in can I use to check whether a shell command is a program or a shell built-in?
I think which,
Close. So what does which do?
Whatever binary it is.
It,
Being actively used.
what?
It's pointing to the binary that's being actively used versus the other ones.
Yes, so which will tell you if you pass which a binary. So if I say which cat, it'll tell me the path to that binary, to that executable.
Where will show you all of them.
Where is not a command, but so yeah. Yes, type. So type will tell you whether or not a command is a binary or a shell built-in. So if I say type echo, it'll say echo is a shell built-in. Now there's a flag you can use. You don't have to know this, but you can say type -a, and it'll tell you all the different variants that exist. So echo also exists as a program on my computer, but the shell built-in is first. So that's what gets run first. How can I use, what command can I use to view help for shell commands that are programs, so not built-ins, but regular programs? So not shell built-ins, but regular programs. Man, yeah. Help is for built-ins. So I can say man cat, I get some information here about cat. If I try to run man cd, I get no manual entry for cd. That's because cd is a built-in. But I can run help cd to get information about cd.
I was wrong about where it's a built-in for a different shell, that's fine.
Okay. Yeah. What shell built-in can I use to view help for other shell built? So we just saw this. This was help. All right. So now on to more complex stuff about processes. How do you redirect the standard out, standard in of a bash command to a file? For instance, if I want to redirect greps standard out, standard in to a file grep.txt, what do I type? Well, bash commands, not C code.
Oh, the less than greater.
Yeah, the less than greater than signs, angle brackets. Yeah. So I could say grep hi, grep.txt, hi, hello, hi. What combination of keys do I press to send the end of input?
Control D.
Control D, okay. And then if I cat out grep.txt, contents are there. I can then run grep again, passing this as the input now, and the one occurrence of hi appears highlighted. Yeah.
So is control key a signal?
Yeah, this is a weird question. Control D is not really a signal. It's not a special character or anything. End of file is kind of its own special thing that I'm not really going to get into, but it's something in between. Yeah. There's a whole history behind it. I can recommend like other sources to read up on this, but
Does that close the right hand too?
is it what?
Does it close the right hand of the thing?
Well, I'm just sending, this is just reading from standard in. So I'm just saying the end of this file is here now. Yeah, that's all control D. It sends the end of file. Yeah, I don't really know what to call it because, again, it's not really a signal. It's not really a character. So, yeah. Okay, how do I redirect standard out from one command to another command? For instance, if I want to count the results of a find with WC, what do I type? Use a pipe. Correct. So if I want to do find here, maybe find just, we'll say, what's here? Yeah, I can just do find here. I can then pipe this to WC to get the number of words, lines, and bytes in the output. So how can I send a signal? Oh, question? No? Okay. How can I send a signal to the terminal to pause a command, run a command in the background, and then run it in the foreground? So if I have a command like this, how can I pause this command? Control Z, and then how do I run it in the foreground? FG. How do if I run it in the background, I can no longer stop it. So how can I stop this command now? Yeah, could use pkill, could use kill all. So pkill, we'll just say find, and that works. If I didn't know the name of this command, how could I, if I didn't want to use pkill, what could I also do?
Look for using PSLX or Fox or.
Yeah, PS, I think just, yeah, PSA will be necessary. I think, yeah, right here, that's all we need. And then you can find the PID right here, so I can copy that. Oops. There we go. And then I can type in kill and pass the specific PID here to kill. And that will also work.
So what does the pkill do?
Pkill searches for, it kills all processes with the name you pass. So you can go to the man pages for pkill to find out. List the process IDs which match the selection criteria to stand out. All the criteria have to match, for example, and you can pass multiple criteria apparently. Yeah, and by default it sends sigterm to them all, just like kill. So all the ones that have a match, it will kill them, or send the terminate signal to them. Okay, build automation. What does the target recipe prerequisite of a makefile do?
The target is the trying to have the recipe, the impact of the recipe is what actions are going to be done once you make it.
Yes, so the target is what we're trying to generate with the recipe, or the rule, I should say. The prereqs are what the rule needs in order to generate the target, and then the recipe are the actual steps, the shell commands you would use to create the target. So I guess I'll create a demonstration, make a makefile here, or maybe what I'll do is make this program first. Hello.c. This will just be hello world, pretty standard. Okay, we can make a makefile. We'll say hello depends on hello.c. Do makefiles use tabs or spaces? Tabs. And then I can say gcc hello hello.c, and then from within vim I can just run make, and that will run my code. I cannot find hello. I passed it backwards, yeah. Forgot the dash o. Now let's try this. And it seems to work. So if I wanted to add an extra source here, how could I do that? Or if I wanted to add an extra prerequisite, let's say I had another file here. Let me move hello.c to be main.c, make a new file called hello.c. And here we'll actually do our printing. And now in main, what we can do instead is just include that file, hello.c. Well, really, we don't want to include a C file. We'll just declare hello. Now we can actually run make, and it's not working. Why is it not working?
main.c dash hello? Or do they not?
So from within main.c, we're calling hello, but in the call to GCC here, yeah,
The method that would do debriefing isn't main, so, sorry, I'm saying this wrong, but we need to tell the program, to, well, first do GCC main.c.
so what we
But
need,
We
okay.
also need to add main.c as a prerequisite.
Yes, so we'll need to add main.c as a prereq because we also need main.c because main.c actually has our main function. And then we also need hello.c because it contains the definition of hello, which we're calling from within main. So ultimately our invocation here needs to be gcc hello.c main.c to form the binary hello. And I can run this down here, and that seems to work. And now I can run hello, and it seems to be like it's working. Okay, by convention, what does the clean target do?
Removes binaries.
So what should we have our clean target do here?
rm-f hello.
rm-f hello. Now, we normally add clean to a list of phony prerequisites as a phony target. What does that do? Why do we do this? Why do we add clean to this phony list? Yes, in case there's a file named clean. Because if there were a file named clean in our current directory and this phony rule was not here, then make would see that the clean file exists and it would say there's nothing that needs to be done and it actually wouldn't run the clean command. So to demonstrate this, I can run make clean and it deletes my hello file. But if I were to create a file called clean and then up here delete that phony rule and run make clean again, now it says clean is up to date. It doesn't actually do anything. So we have to always add our clean rules to a phony list here, and then make clean will actually work, whether or not there's a file called clean that exists. So in general, whenever you have a make rule that doesn't actually produce something, but is more like a command you want a shorthand for, you want to add it to your list of phony targets. Yeah?
Do you know how like when you're like compiling the make, you say make and then you compile with like /hello or whatever? Could you add that to the make file so it's like completely automatic? Or?
You mean you run with /hello? You run the program with /hello? You could. So I actually done this before. Sometimes what I'll do is I'll make a rule called run. And what I'll do for the run rule is make it depend on the target and then just run that target. So you can see right here there's the binary doesn't exist. The hello binary doesn't exist. But if I run make run, then we'll compile and run it for me. So sometimes this is a good idea to do this. What's more useful instead of run is to have a target called test. That way you can automate all your testing as well. So I think I showed this in the previous lecture, how you can quickly accelerate your development workflow for the proc project by adding these sorts of test rules to your make file. So you can always add this, and yeah, we have this, and then make test, and it actually runs the program. And what I could really do if I wanted to be very clever is I could use like a command like diff to compare this output against some output that I know is the correct expected output for this program, and I could check everything is working, but I'm not going to do all that right now. Just you could know that you can add test rules to test your projects with make automatically with just a press of a button. Okay, where were we? Here. Okay. So I think this would be a good point to take a break and take attendance. If you have any questions, you can ask me. I'm going to pause the recording now. Okay, I think we can continue now. So let's go on to version control. What git command stages a new file? So actually, I guess before we should do that, what git command creates a new repository? Yeah. Yep, git init. So we have a new repository here. How do you know it's their git repository? What is, I guess it already tells you here. There's the .git directory. All right, so what do we use to view the status of our repository?
Status.
Yeah, self-explanatory. Bit of a harder question. If I wanted to explicitly exclude a file from version control, what can I use? What file do I use to do that?
The ignore button.
Yeah, .git ignore. So I could say vim.git ignore and add the hello executable binary here because I don't want to push my binary to source control. And now if I run git status again, the hello binary is excluded from consideration. So you might want to add those to your projects to exclude your project binaries. We don't give them to you by default, but it's worth maybe trying to do. Yeah.
The add command would overwrite that if you did it, right? Like if you went and did git add.
Yeah, I believe you can explicitly overwrite it. You might need another flag too. I'll try it. Actually, it says ignore, but we could say -f. Yeah, it tells you. So. Okay, so if I wanted to stage a file from the working directory, stage it for potentially being committed, what do I do?
If you git commit in the file name.
Okay, so you might have skipped a step there. How do I put the file to the staging area? Add. Git add first. So I'll say git add, and I'll add everything here right now. Actually, probably remove that grep.txt file. And yeah, everything that I wanted to add, I'll also add the .git ignore. Add all those. And it'll be all staged too for commit. So right here. So how do I don't want to use the word, but add these files to the local repository, like commit, yeah. Git commit, and I can just say initial commit. Now if I run git status, you can see it's all good. It's all good to go. If I wanted to add a remote, what would I use? So I would use git remote add, and then I could type in the name of the remote repo. For you, it's always going to be git remote add submission, and then the URL. We've been using that in this class. You mostly just had to copy and paste that command, so you don't really need to know it explicitly. The really important ones are git status, add, init, pull. So what does git pull do? Yeah, grabs changes from a remote repository and synchronizes them. So maybe I should open up my diagrams here to help explain this as well. Scala draw and version control right here. So we had said git add, move from the working directory to the staging area. Git commit goes from the staging area to the local repository. And then what command goes from the local repo to the remote? Git push. And then if I wanted to create a fresh repo that's a new local repository, it's a clone of an existing, well, I just said it. Git clone. Yeah, it's hard when you use these commands a lot not to use the terminology. So we can drag it over here. Oops. Just put in parentheses git clone. And now if I wanted to synchronize my changes with the remote, add the remote's changes to the local repository, what command do I use? Not fetch. Git fetch is a command, but it's not the one I'm talking about. Pull. Yeah. So I would say here, oops, it's an ugly line. Draw it like this. We'll say git pull. So pull is specifically for changes from an existing repository, or from the local to an existing repository. Clone is for copying an existing remote repository freshly to your machine. Yeah.
Should the clone arrow be flipped?
Yeah, it should be. It should be. I was initially meaning putting it there to mean that it's linked to the remote, but yeah, if we're considering it as a copy, then yes, it should be flipped. Yeah.
Let's say you don't have a remote repository and you wanna kind of, since it is version control, let's say you wanna go like a little, like 2 versions behind, how do you do that?
What do you mean you don't have a remote repository, but you want to go 2 versions behind?
Do you always have to have a remote repository?
To go back to a previous version of your program?
Yeah.
No, no, you can always do, so let's say right here, for instance, git status. Sorry, so I think my working tree, yeah, it's clean. Let's say I want to change my hello file here to say hello world. I'll run make test. My program seems to be working, so I add the change, git add hello.c. I'll add a message here, change output. Now I'm back, my working tree is clean again, all my commits are staged. I can run git, what command can I run to view the previous commits that I made? Git log, I can see all my previous commits. If you want to go back to a previous commit, let's say I've realized, oh no, I shouldn't have changed this output. The customer doesn't like that or something. I could say git checkout, and I can pass a commit hash here. So I can actually just copy this commit hash, oops, and then go straight to it.
Okay.
And now you can see I'm in this current state here. Now if I run make and run my program, hello, it'll actually just say hello. Yep.
Is that different from revert?
It is different because you're going back to a previous position in the commit history. You're not undoing any changes. So now if I run git log again, or git, I forget what the command is here, git checkout head, I think. Main, or maybe, yeah, main. It goes back to the commit, the commit that I'm currently on. Yeah. So I'm not going to get into all these details, but since you asked, I figured I'd show you. But there's like there's books you can read on this pro Git. It's online, it's free. There's a bunch of resources you can use to learn more about Git. But that's sort of the benefit of Git, is that you can, if you make small changes over time, then if you accidentally introduce a bug, you can go back to a previous version of your program and identify when the bug was introduced that way. Also, as a professional software engineer, if you manage to get a career, or if you want to be a professional software engineer, when you're a junior developer, you often have to upload your code for code review by senior developers. And they'll be wanting to read your code as quickly as possible and leave comments on it. It's much easier for them if you make small commits that make small changes over time. And there are lots of ways. I would recommend installing, honestly, maybe this is like outside the class's scope, but I'd recommend installing plugins for using Git when you're working in your own editor, because with those, you can actually commit specific changes at a time. So I guess to demonstrate this, you can see when I type in here, if I type in hello again, my editor actually tells me the specific lines of code that I changed. So I can actually make very specific commits. So if I were to make another change up here, making me declare another function void by, I don't have to commit the whole file. I can just, there's key bindings that I have set up, commit just that change, and then I can say call hello twice. And now just that one commit has been staged. This commit's still not staged yet. So I recommend, again, outside the scope of this course, but in the future, outside this course, I recommend doing this, looking into getting plugins that let you get very fine-grained control over what commits you're pushing to source control. That way, when senior developers review your code, they can review it more quickly and give you better feedback. Yeah.
You say small commits. How small is small?
It should be, I mean, that's kind of up to debate, right? But I would say like logically connected. So if you're fixing typos, only fix typos. If you're making comments, only make comments. If you're trying to add a test case, write enough for the test case to work. And yeah, functional. So every commit should ideally result in a program that still works, that the test cases should still pass afterwards.
So like the smallest functional, reasonable change.
Yeah, I mean, again, this is objective, but yeah. Okay, so again, that was kind of not really necessary, but I think arguably necessary if you want to be a good software engineer, so I say it. All right, so now on to the last two sections. We're making pretty good time, yeah. So file syscalls. I guess any questions before I move on? Any questions about version control, build automation, any of the things we saw so far? Okay, so file syscalls. Use the open syscall, man to open, not fopen, to open a path given in the string char star file path variable. So let's create a program for doing this. Just going to remove everything that I have. Sorry. I'll remove .git and .gitignore. Why is that reproductive? Okay, that's fine. Cool. So we'll just create a program called read.c. So if I wanted to open a file with the open syscall, how would I do this? Let's say I have a file here in the right. Again, I'll just say echo hello and redirect it to a file called hello.txt. How could I open this file from within C here?
Create a FD variable, and then you set it equal to open and the file name as a string, and then the O create, or depending on what you want.
So we just want to open it for, let's see here. Let's just open it for reading. Let's just open it for reading, let's say.
O underscore RD.
Okay. So what does FD stand for? Yeah, file descriptor. So what is a file descriptor?
If it's 0 is standard input, 1 is standard out, and 2 is standard error.
Okay, so those are examples of file descriptors. But what is a file descriptor more broadly? Yeah.
It's an ID to distinguish different files.
Yeah. So what's really going on under the hood is that each file descriptor refers to a description, an entry in the open file table, and those descriptions point to inodes inside the kernel. So inodes refer to all files, but open files get entries in the open file table, and file descriptors point to those open files. So I think I have maybe some slides here that show this. Which one then was it that had this? Maybe it was redirection? Yeah. This shows you the whole, all the details. Usually for our purposes, the inode table is not really necessary to look at for what we do, for our examples we've gone over, but this is the whole mapping. Okay, let's go back to the questions then. Again, let's actually try running this, I suppose. I'll make a makefile real quick. And what I'm going to do now to make this faster is I'm going to create a makefile that just quickly compiles all of the .c files into binary files. So we'll just say sources equals, actually, I'll just do this by hand actually. Probably better just do this by hand. I'll issue the makefile for now. Read.c-o read, and then a.out, or read.read. So we have an error, read only is not defined, so we have to do what? Include the appropriate header, so we can do man to read. Why do we have to use to in man to read? Yeah, for syscalls. That's a syscall section of the man pages. So we'll include use.h. And since we're opening a file, what should we also do afterward? So close FD. Sorry, keep reading that I don't have a makefile. We can run this, and we still have an error. Let's see. Man to read. Let's see. Why is that not defined? Oh wait, sorry. Man to open, I'm typing in the wrong syscall name. So it should be fcntl, function control, file control. I keep typing make instinctively, but all right. And now make is undeclared, so we'll have to look at the man pages for make. And this is declared in unistud, so we'll put that back. And now it finally works. So don't worry about getting the headers right on the exam. I will not ask you to remember the headers. I will not ask you to check for errors on the exam either. But you should know how to do that. So next question, how can I check that open succeeded?
If FD is not negative 1.
So if FD is equal to -1, then we have an error. What should we do in case of an error? So we use p error. We'll say, what do we pass the p error?
The command.
Yeah, the name of the command that failed, so we'll say open in this case. And then exit with, we can say exit failure, which should be equal to 1, just some non-zero value.
Standard IO.
Hmm?
The header file.
Yeah, we need the standard IO. So this should be in manual page section 3. So this is going to be std IO. Yep. Now if we run this, compile this again and try to run it, let's see, we get another error because of exit failure not being defined. This should be in standard lib. Yep. And now it seems to work. How do you check for and terminate the program on an error with opening a file? Well, we just did that, checking for -1. So now let's use the read syscall to actually read from a file. So let's look at the man pages for read. We need to pass what to read? We need to pass a file descriptor. We have that. We need a buffer for storing what we have read. So we'll create that. This has to be any type we want. We'll just say avoid buff count. So we'll say char buff. We'll just say 4 bytes. We'll just read 4 bytes. And then we need a count, how many bytes we want to read. We'll set count equal to 4. So what does read return?
The number of bytes that you read.
Yes, the number of bytes read. So why might read return fewer bytes than we request? If yes, we reach the end of the file is smaller than the number of bytes we requested. So let's try calling read here. So we've opened the file, and we can call read. Let's actually declare a variable for storing the number of bytes read. What is this s size t type? Signed size type. So it's a size type, which means it's appropriate for like storing the number of bytes read and stuff like that. And it's signed because read can return -1 in case of failure. So it has to be signed to support that. So we'll say bytes read is equal to read. First thing is the file descriptor. Second argument is going to be the buffer. And last argument is going to be the count. If -1 is equal to bytes read, and we can we'll just copy this, paste it in, and change open for read. And now we'll try running this again, and it seems like everything is still working. So this says to read the first 200 bytes in the file and print it out. We'll just read the first 4. The number doesn't matter. How can we, yeah.
What is the buffer for?
The buffer, it's for storing what we read from. So now the buffer should store, actually this will kind of answer your next question, or your question, what I want to do next. Let's try and print what's in the buffer. So we can actually see what the buffer just had in it. So we can do this with printf. We can print what's in the buffer using printf. But let's try using the write syscall instead. So man to write. We have to first pass to write the file descriptor we're writing to. So if we want to write to standard out, what file descriptor should we use?
std out underscore file.
Standard out, file no. What should that be equivalent to?
Start with
1, right? And we pass a buffer, which is what we're reading from, or we're writing from, I should say. And then we're going to pass the count, the number of bytes we want to write from the buffer. So we'll say 4. Or we can just say count as well.
Do you not pass the bytes read?
Yeah, I'm assuming they'll be identical, but you're right. To be really safe, we should pass the number of bytes read, so to make sure we're not accidentally writing more than we actually read. So, yeah. We can run this, and now we actually have, oops, just the first 4 letters, which is not really a very nice word. So maybe I'll change this to be the first 5 letters. And there we go.
So is the buffer always the count size?
Is what buffer what?
The buffer always the same as the count size?
The buffer can be bigger than the count. It's just the maximum number of characters we're allowed to store in the buffer. So in this case, we get the same result, but if we were to inspect the contents of the buffer, the first 5 would be hello. The remaining 19 elements would be just garbage, arbitrary garbage. Yeah.
If the difference between the SS size and just the regular size is just the sign or unsigned, is it safe to just always use the one with the double S?
So sometimes you might want to store a very big number. And I don't know, you've all taken computer architecture, computer logic, right? Computer logic and organization. So you should be aware that the way numbers are stored in a computer, they typically use 1's complement in their binary representation. And what that entails is reducing the maximum number that you can represent with that binary representation. So sometimes you might want to avoid using the sign size type in order to get an even larger maximum representation of your values. And maybe sometimes you don't want to represent negative values at all. It might be erroneous to even allow negative values in your program. So you want to avoid that by just using a unsigned type instead. Okay, so you should probably check for the bytes written as well, since we do get that back from write. So over here, it's a bit smaller. There we go. Okay, just to be sure, and yeah, no errors. Okay, what's this call can we use to find the size and number of hard links of a file? Stat, exactly. So we're going to be using the stat syscall now. So let's see, man to stat. And we can see that this requests that we pass the path name and then a stat buff. So what is this stat buff struct? What is it used for? Why are we passing it by pointer here to this function?
It's going to hold the data that comes back from stat.
Yes, we're going to get the results back from the call to stat. So now let's try calling this. So we'll say, let me actually create a char star here, file path, and we'll just change this out for hello.txt. That way we can refer to it again later. So let's assume we're done with all the stuff we were doing up there, and now we'll try calling stat. So we'll say stat file path. We need a stat buff, so we're going to have to declare that. So we'll go up to the top here. Struct stat statbuff. And here we'll have to use the ampersand to get the address of that local variable. So that way we can pass it by pointer. So we need to use the ampersand to get the address. We'll check for an error. And now this should be fine. Oops. You have to include the appropriate header. So this is going to be declared in sys/stat.h, so we'll add that here. So we're not getting any output though relating to the stat, to the stat of the file. So let's print the size and number of hard links. So how can we view the contents of the stat struct? Man3 stat, so that tells us the stat struct. We're not going to be looking at the file mode, but does anyone remember what man page section contains the mode information of the file, like its permission bits and whatnot, and whether it's a regular file or directory file?
7.
Man 7, the section is 7, and what's the entry? Inode, man 7 inode. So man 7 inode, if we scroll down here, it actually tells you, gives you some fields, some macros you can use for actually checking if a file is a regular file or a directory file, and so on. They give you some more complete examples, I think. Maybe not here, but yeah, they give you this small example at least. So for us, we just want to access the size and number of hard links. So to do this, we'll just say printf, and the format specifier we'll use is JD. So JD specifies that it's an integer up to the maximum size integer on my platform. You don't have to know what the maximum size is in advance. It's just supposed to be platform independent. So we don't know what these types here in the right are defined as, like off-t for size and nlink t. We don't know what they are. We just know they're integer types. So we're supposed to use JD to say whatever size they are, support up to the maximum size integer on our machine when printing them. So that's what we're supposed to use. So we'll say size. And what field is the size? What field on the right here?
ST_size.
ST_size. And now let's say number of hard links. Which one is this? Nlink. Yep. So let's try running this now. And there we go. Well, we still have the message from earlier kind of colliding with what we were trying to print here. So I'll just change this to just give us a new line. There we go. Okay. What system call can you use to find the name of a file? If you want a hint, look at the next question. ls is a shell command. What syscall returns a struct that has the name of the file as one of its fields? You should all have been using this for the myfind project, unless you all haven't started until you haven't started it yet, which I hope not, since it's due in like a few hours. So what library call opens a directory?
Let's see, open it here. You can create a pointer to a directory and then use opendir to get a pointer to that, get the pointer address to that.
Okay, so really this isn't a syscall actually, it's a library call, I realize that now. What library call should we use to do what you're describing? Yeah.
So we would use readdir after we've opened the directory, we use readdir, and then part of that struct is it has the
Yes, exactly. So we use open dir, open the directory, read dir, and then close dir to close the directory. So let's do that now. So we'll say man3 open dir. That's going to be sys/types.h. I think we already had that. No, we don't. So we'll fix that. And then we also need dirent.h. So we'll get those two. And now what we'll do is we'll say, we'll open the current directory. So the return type of open dir is a dir pointer. So we'll say dir star dir p equals open dir, and we'll just open the current directory. Down here, we'll make sure to close it. Close dir p. But in between here, how are we going to walk this directory? Yeah?
So we use a while loop, or we can assign Dexter is the loss to it. Basically, what if check while Dexter is null.
Yeah, so while, and we can say while null is not equal to, well, we need a directory entry, so let's open up the man pages for read dir. You can see that it returns a directory entry struct dirent, so we'll declare one up here, dirent pointer dirent. And we'll say while null is not equal to dirent equals read dir p. Now we are walking the directory, so now the dirent struct should have, or variable should have the fields for this directory entry. And those are going to be according to this documentation here, which is kind of garbled up. Okay, there we go. The name should be in the dname field, so we can print that. And it says it's null terminated, so we don't have to, we can use %s when printing it. So we can say printf %s \n dirent arrow d underscore name. There we go. So if we wanted to avoid printing the current directory or the parent directory, what could we do? Okay, you can go ahead.
A sort of brute force solution would be to just check if the name of the directory is dot.
Yeah.
Continue.
Yeah, exactly. So we can just simply say here, we'll have to include the string library to do this, the string header.
It's funny, because I thought I was gonna say that, but I thought there has to be a better way.
That's, maybe there is, but that's the only way that I know. Yeah, I don't know. But unfortunately, that's the best way that I know as well. So string comp dot, we'll do the dirent dname first. And then dot. So what does string comp return when two things are equal? Two strings are equal?
0.
0. So we'll say if 0 is equal to that. We'll do nothing. Else if 0 is equal to that. We'll also do nothing, and then else we can print it out. Now if we run this, we don't print the dot or dot directories. So there's better ways to do this. We could probably make our code a little bit cleaner here. We could copy that, make that a separate condition in here.
And then just say if it's not equal to 0, then fine.
And then you could just do that as well. Yeah, you could say if string comp here or string comp here, move the double parallel bars there, and then we'll just say here, and we can remove the else statement then. Oh, oops. Yeah, got it. Yeah, there we go. No.
Just because you got,
Yeah.
just because you got the not and you switched it to.
That's what, yeah, I did it twice. De Morgan's Law. So, okay, yeah. So we can skip printing the current directory and the parent directory by just comparing the strings. So I think this should be familiar. Hopefully you all have seen this before, because you had to have done it for your MyFind project. You should have done something similar to this, walking the current directory and printing out its contents. So I would recommend being familiar with how to do this. And what's the one? How do we check for errors with redir? What's like the tricky thing with redir with checking for errors? Yeah.
You can check if it's null and then send a error message to STD error.
Okay, but does redir only return null if there's an error?
-1?
So redir does return null eventually. It will return null when there's no more contents left in the directory that we're iterating. So it may not be an error for redir to return null. So the man pages actually call this out. Oops. If the end of the directory stream is reached, null is returned and error no is not changed. If an error occurs, null is returned and error no is set to indicate the error. To distinguish end of stream from an error, set error no to 0 before calling redir and then check the value of error no if null is returned. So the way you're supposed to do this in practice is set error no equal to 0. And then after walking the directory, you can just check if 0 is not equal to error no. Then you can print your error messages. So this wasn't really something that was explicitly shown to you in the MyFind project. If you didn't do it, I don't know how. But the idea is that you were supposed to read the man pages to see how to correctly check for errors for using redir. And it was pretty clearly spelled out in the return value section, error section. So. But again, also the project's not due until tonight, so if you didn't add that and you want to add it, you can. If your project's working anyway, you don't feel like you need it, then don't worry about it, but you probably should add error checking. So I'll have to include error no in order to get access to that variable, error no.h, and error. Yeah.
So does the error node value, like, is it based on how many errors it finds, or is it just like one iteration?
It's only the last error. Yeah. So error no is basically a global variable. It's used for storing the last error that occurred in a syscall, library call. Sometimes use a 2, I believe, or they do. As you can see right here, this is a library call. I personally hate the idea of using error no. It's a instance of what's called out-of-band error reporting, where your error is not included as part of the return type, the return value. So other programming languages have what's known as optional types, where a type that you return can be either like a null type or have a type that actually has a value inside of it. C doesn't really have that. We just have pointers, and that's not really the same thing. So instead, people writing the standard library, they have this idea of checking for an error using error no, and then if you have an error, using p-error to actually print the value of that error, what it actually is. It's really kind of messy, if you ask me. And also, it doesn't work well in multi-threaded applications or scenarios where maybe multiple syscalls fail at once and they both overwrite error no, and now you don't know which one was the one that actually failed, or you don't know which error message actually happened last. So there's a whole bunch of problems with error no, but that's not really necessarily relevant to the course, but just figured I'd mention it since you asked about it. Yeah. Okay, so let's go on to the next part here. Okay, we just did this, so we're on to the last section now. So write code that creates a new process where the original process writes parent and the new process writes child, both to standard out. So I'm going to delete everything we have so far just to clear up some space. So what syscall do we use to create a new process? So we'll say switch fork. What is -1?
Error.
So we'll say p-error, fork. What is the child? 0. The parent's going to be default. So in the child, we want to say child, so we'll just say printf child, and in the parent we'll say, is this fine?
Gotta wait.
What?
You both have to exit for the child, like underscore exit, and then you also have to wait for the parent.
Yeah, so we don't need to wait for the parent necessarily in this case, but we should. It's good practice to wait for the child. So we can wait for the child here. And we can include, I think it's sys/wait.h. I think that's what we have to include for wait, or maybe it's types. Let's find out. It's wait.h. Okay. So the file is not really named. It doesn't really make sense to call it read.c anymore, but oh well, we'll keep going with that. And yeah, we get parent, and let's see, we didn't get child. Does anyone know why we didn't get child?
You didn't flush it.
We didn't flush, so we forgot to flush. F flush, yeah, standard out. And there we go, child parent. We forgot the new line characters as well, but yeah. So does anyone remember why that's a problem? We didn't flush the streams, the buffers. Why that's a problem?
There's no exit visit with like by default.
Yes.
So underscore doesn't flush, so you have to write the rest.
But you're right. Underscore exit doesn't flush. Regular exit does flush. That's what's important for, well, that's what's relevant to you as a programmer, immediately relevant. What's going on behind the scenes is that outputs are buffered. They're stored in memory. They're not immediately written to the device. This is for performance reasons, improved performance. Now, if we use underscore exit, that does not necessarily flush all the buffers. So actually update the storage mediums or the terminals with the contents in the buffers. We have to manually do that when we're using underscore exit. We do that with the fflush command over here, or function, I should say. Yeah.
I'm not sure if you mentioned it, but why do you flush in the child?
Because the child exits with underscore exit. And underscore exit does not flush any buffered outputs. Regular exit does. So we need to flush manually before exiting with the child. And does anyone remember why we use underscore exit in the child and not regular exit?
Regular exit sends certain signals that you probably don't want to send if the parent process is still.
So similar to that, yeah. Regular exit triggers exit handlers. So there's syscalls like add exit, and actually it might be a library call. Yeah, add exit, which you can call and then set up a function to be triggered when the program exits. Now, underscore or regular exit will trigger that, but we may not want to trigger that in the child and only trigger it in the parent. So underscore exit is to prevent having the child call an exit handler that only should be called by the parent. This could be things like deleting files or maybe saving some cached results to the disk or something. You may not want the child to duplicate that action. You only want the parent to do that. Okay. All right, so let's go back to the next question here. Write code that replaces the current process with the current running program. The current process is running program with the stat ls command, not the syscall. So let's try just doing stat. We'll do this in the child. So what syscall can we use to replace a running process, a process? So exec, we'll use LP. What does the L mean? List, so we can put the arguments directly into the function call. We'll do ls as the one argument. Why is the first argument the same name as the program itself?
Convention.
Just a convention, yeah, we're supposed to do that. All Linux programs have that as their default. And then null is how we end the list. What does the p mean?
Access to path.
Access to the path, so we don't need to specify the full path to these programs that are in our user bin directory. Now if we run this, I didn't save the changes. Then we see the contents of this file printed out to standard out. Contents of this directory printed to standard out. Should exec return? So what should we return in case afterward? 1, or exit failure, just some non-zero value to signify that exec it did not succeed. Write code that uses Unix standard syscalls to create a new process that runs the ls command. Well, we just did that. We forked and then exec, so that was it. Write a program that opens a pipe and then reads to and writes from it. So how can we open a pipe? Okay, so what syscall do we use for creating a pipe? Yeah, pipe, and what do we pass?
Like that B.
Pipe FD. I think it should be pipe FDs actually is what the man pages say. Oh no, it just says pipe FD, okay. Pipe FD. We'll skip error checking, but you should check for errors. And yeah, we can define an enum for the read and write ends of the pipe. We can say read equals what? What is the read end? 0. What is the write end? 1. Now, we call pipe to create the pipe. Now we want to, in the child, let's write to the right end of the pipe, and in the parent, read from the read end of the pipe. So in the child, what should we do to read from the read end? Redirect our standard in to the, or standard out, I should say, to the right end of the pipe. So we'll say dupe 2. What should be the first argument? Pipe FD. We're redirecting the out. So we're going to say ls wc. Let's say that's what we want to emulate. ls to wc. So what should be the arguments to for this? 1, which is the right end of the pipe. And then what should be the second argument? Standard out file no. Okay. And now, should we close anything? We should close the read end.
Well, before, but this one you close it.
Sorry, read end. Because we're not going to be reading from the child, right? And now after we've successfully performed the redirect, what else should we do? Close the right end. So ultimately we close both ends of the pipe in the child. Okay, and now in the parent, we're going to do something similar. We're going to close what? The right end. Let's move this down here and we can get a better look at it. Keep it for easy reference. Now dupe 2 again. What are we duplicating this time? So the read end, yeah. Pipe FD read. Standard in file no. And after that, we close the read end because we have successfully duplicated the descriptor. We no longer need to have an extra copy of it lying around. And should we wait for the child now, or where should the call to wait go?
Wait should go first.
Wait should go first. We wait for the child. It doesn't really matter in this case because, well, yeah, it doesn't really matter in this case, I don't think.
It'll wait for something to read anyway.
Yeah, will block. Read is a blocking operation, waiting for input to be available. Yeah.
Wait, does the exec go after the write is closed, or when do you
So you're right. We forgot to call exec. So where should we put exec?
before the read is, or after?
After the call to close, right? So we make sure that all the file descriptors are closed before we actually call our next program, before we replace the running process with WC.
Why do you have to wait till it's closed?
Why do you have to wait till what?
Yeah, it's closed.
It doesn't really matter in this case, waiting, because Okay, let's try it like this, and then I'll explain it, moving it around, and we'll see what happens. So it seems like it worked, so I can do this here on the right-hand side. It gives me the same output, running our program and doing the shell command manually. It seems to work. If I move wait down here and run it, it still works. Now the reason why is because wait says to wait for the child process to finish running. So up here makes sense because we wait for the child to finish, then the parent tries to use WC to read in what the child printed. Now down here might be a little more confusing, or right here is more confusing, but this still works because read is a blocking operation. So if the parent tries to read from the read end of the pipe, but there's nothing in the pipe, the parent will wait until there has been something written to the pipe for it to read. And then it will continue executing.
You didn't actually run it with null below.
Like this? Yeah. Yeah. So the parent, it will still work, just the parent is waiting on the child to print something anyway because the parent is trying to read from a pipe, which may not have anything in it. So I think we have a few minutes, so I'll try and illustrate this. This is the last, also redirecting standard out to a file. We know how to do this. That would just be, do you want to see that as well, or should I? Redirecting to a file, or is from a pipe fine? Okay, so we have examples in the previous lectures of redirecting to a file. It's the same idea as redirecting from a pipe. You just open the file first and change out pipe FD for FD, for whatever file you're writing to. Just to quickly illustrate the last thing here. Yeah. So I'm trying to revise the pipes lecture because I didn't like how it went last time. I want to use more of the file tables. So if we have our parent process shown here, we've opened the pipes, so we have the read end and the write end of the pipe. So read will be at file descriptor 3, write end will be at file descriptor 4. So a little bit here. So at this point we have called pipe, created the pipes, it's available in the parent process. If we call fork, that will duplicate the parent, including all open file descriptors. Oops, let me try and copy these arrows too. Oh well, I'm gonna have to copy them manually, I suppose. Okay, I'll do this in a different color to signify that it's the child. So the child receives copies of the parent's open file descriptors. They point to the same places. So in the child process, we close the read end of the pipe. So in the child, we close this end of the pipe. We call dupe2. So what will that do to this child process down here? So dupe2, standard out file no. So what does dupe2 do to the second argument first? It closes it, so it's going to close standard out, and then it's going to what? Reopen it, pointing to the right end of the pipe, 4. Yeah. So, and then we're going to close the right end of the pipe because you've already redirected standard out to point to that. Now in the parent, meanwhile, so we're going to call exec, the child will become ls, and we'll print some content, some output to the pipe, so the pipe will have some output waiting in it. Now in the parent, we're going to close the right end of the pipe, so the right end of the pipe should be, oh, these are all messed up, all these lines. I think that's better. Okay, that's better. Okay, so we close the right end of the pipe. The right end of the pipe is going to be at 3. or 4, I should say, 4. We're going to duplicate standard in, so what do we do first? Close it, and then reopen it, pointing to where? Read into the pipe, which is which one? 3, so we'll drag that down here to 3. And now, do we need to read into the pipe anymore? No, so we can close that as well. And the parent waits for the child to finish running. It'll have to wait anyway, because it's waiting for the outputs to be placed into the pipe, because it's reading is a blocking operation. And then it calls exec LP, reading from the read end of the pipe, and then running WC on what it read. So I hope that was illustrating. Yeah.
Quick question about the midterm, for the short answers and the long answers. This is mostly coding, like short coding. How strictly are we going to be grading as far as?
So I have, it's going to be pretty permissive for the short response and long response, and I also give you a point breakdown on what every single part of the question is worth. So the instruction is going to be pretty clear, and it's going to be clear how many points they're all worth, and I'm going to try and be a little lenient in the grading for syntax errors and stuff like that. But make sure you know the correct syscalls to call and the correct order. Yeah. So. All right, well, I'll see you all next Monday. Good luck.
So is CI/CD for software engineers now?
CI/CD?
Yeah.
Let me save the recording here.